I, Syed Basharat Ali, Junior Lecturer in the Department of Electronic and Communication Engineering, working at Government Junior College, Chanchagoda, Hyderabad. Today, I am going to teach second unit of paper 3, that is CRO and frequency generator. Let us start with the full form of CRO. CRO stands for cathode ray oscilloscope. Basically, CRO is an electronic test instrument used to obtain waveform when the different input signals are given. It is a test instrument which allows you to look at the shape of the electrical signal. In this slide, you can see the picture of CRO, that is cathode ray oscilloscope. CRO is the most useful and versatile instrument used to display the various waveforms which can be analyzed. This figure gives us the overview of measuring voltage and time period through CRO. CRO is basically an XY plotter, which means it is going to plot a signal on x-axis and y-axis in sinusoidal waveform. Let us define the terms amplitude, peak-to-peak voltage, and time period. Amplitude. Amplitude is the maximum voltage reached by the signal. It is also called peak voltage and it's measured in volts. Peak-to-peak voltage. Peak-to-peak voltage is the distance from the lowest negative amplitude to the highest positive amplitude. Nothing but it is twice the peak voltage. Time period. Time period is the time taken for the signal to complete one cycle. In this figure, we can observe the variation of amplitude through time. Measurement of voltage. Voltage is shown on the vertical y-axis and the scale is determined by Y amplifier. Voltage is equal to distance in centimeter into volts per centimeter. Let us observe how to calculate peak-to-peak voltage and amplitude from the given sinusoidal wave. As you can see, the maximum voltage is 4. Hence, peak-to-peak voltage is 8 and amplitude is 4. Definition of frequency. Frequency is the number of cycles per second. It is measured in hertz. Frequency and the time period are the inverse of each other. Frequency is equal to 1 by time period. This slide gives you the visualization of dual trace oscilloscope. Dual trace oscilloscope can display two traces on the screen, allow you to easily compare the input and output. This is the block diagram of dual trace oscilloscope. As we can see in the figure that it has two individual vertical input channels, namely A and B. Both the input are separately fed to the preamplifier and attenuated stage. The outputs of the two separate preamplifier and attenuated stage are then provided to the electronic switch. This switch only passes a single channel input, particularly at a time to the vertical amplifier. The circuit also has a trigger selector switch that permits the circuit triggering with either A or B channel input or with the externally applied signal. The signal from the horizontal amplifier is fed to the electronic switch by either sweep generator or channel B by switch S0 and S2. In this way, the vertical signal from channel A and horizontal signal from channel B is provided to the CRT from the operation of oscilloscope. This is the XY mode of the oscilloscope and permits accurate XY measurements. Basically, the mode of operation of the oscilloscope rely on the choice of front panel control. In order to produce two separate traces, basically two methods are used, namely alternate and chop mode. Waveform of dual trace oscilloscope. Whenever we activate the alternate mode, then it permits the connection between both the channels alternately. This alteration or switching between the channel A and B takes place at the beginning of each upcoming sweep. Also, there exists synchronization between the switching rate and the sweep rate. This leads to the spotting of traces of each channel on one sweep. Like in first sweep, traces of channel A will be spotted, then in the next sweep, traces of channel B will be considered by the CRT. In this way, the alternate connection of two channel input with the vertical amplifier is performed. The change in the electronic switch from one channel to the other occur at flyback sweep duration. At the flyback period, the electron beam will be invisible, and so the changeover from one channel to other. Hence, a complete sweep signal from one vertical channel will be displayed at the screen, while for the next sweep, the signal from another vertical channel will be displayed. This method allows us to maintain the proper phase relationship between signals of channel A and B. However, along with advantages and disadvantages factor is also associated with this mode. Alternate mode leads to a display that will be shown the occurrence of the signals at different time. But in actual practice, the two events occur simultaneously. Also, the method cannot be used for the representation of the low frequency signal. Waveform for chop mode. In this mode of operation, during a single sweep, several times switching between the two channels occurs, and this switching is so quick that even for the very small segment the display is available at the screen. Here, the electronic switch undergoes free running at a high frequency of about 100 kHz to 500 kHz, and the frequency of electronic switch does not rely on the frequency of sweep generator. Hence, in this way, the small segment of two channels get connected to the amplifier in a continuous manner. When the chopping rate is faster than the rate of horizontal sweep, then the separately chopped segment will be merged and recombined to form originally applied channel A and B waveform screen of CRT. However, if the chopping rate is lesser than the sweep rate, then it will be definitely lead to the discontinuity in the display. Therefore, in such case, alternate mode is more suitable. Digital storage oscilloscope. A digital storage oscilloscope is an instrument which stores a digital copy of the waveform in the digital memory. In digital storage oscilloscope, signals are received, stored, and then displayed. Digital storage oscilloscope used to measure the capacitance, inductance, time interval between the signals, frequency, and the time period. This is the visualization of digital storage oscilloscope. Frequency measurement. If the two frequencies are same, we will obtain a simple figure on the screen of the CRT. The shape of that figure being dependent upon the phase shift between two AC signals. The first picture is that of Lessage's figure formed by two AC voltages perfectly in phase with each other. If the two AC voltages are not in phase with each other, the straight line will not be formed. Rather, the Lessage's figure will take on the appearance of an oval, becoming perfectly circular if the phase shift is exactly 90 degrees between the two signals if there is amplitude are equal. In this figure, we observe two AC signals are directly opposing one another in 180-degree phase shift. The more complex the ratio between horizontal and vertical frequencies, the more complex the Lessage's figure. From the figure, we observe the horizontal frequency is 3 times that of vertical frequency. Amplitude measurement with CRO. For amplitude measurement, you count the number of vertical division occupied by the signal's vertical signal and then multiply by the vertical scale. Measurement of phase using CRO. Cathode ray oscilloscope is used to determine the phase difference between two signals of the same frequency. The procedure is to apply one of the signals to the horizontal deflecting plate and the other to the vertical deflecting plate. The result is a pattern that reflects the character of the phase difference. This is the block diagram of audio frequency signal generator. The signal generator is called an oscillator. A Wien bridge oscillator is used in this generator. The Wien bridge oscillator is the best for the audio frequency range. The frequency of oscillations can be changed by varying the capacitance in the oscillator. The frequency can be also changed in step by switching in resistors of different values. The output of Wien bridge oscillator goes to the function switch. The function switch directs the oscillator output either to the sine wave amplifier or to the square wave shaper. At the output, we get either a square or sine wave. The output is varied by means of an attenuator. The front panel controls of AF oscillator consist of frequency selector switch, frequency multiplier, amplitude multiplier switch, symmetry control, output variable. Frequency selector switch. It selects the frequency in different stages. Frequency multiplier. It selects the frequency range from 20 Hz to 1 MHz. Amplitude multiplier switch. It alternates the sine wave in 3 ranges, x1, x2 and x3. Symmetry control. It varies the symmetry of the square wave from 30% to 70%. Output variable. This provides sine wave or square wave output on-off switch. Application of AF oscillator. The AF oscillator are useful for service shop, production and testing department, educational institution laboratories, amplifier frequency response, tone control test, amplifier performance evaluation using square wave, amplifier overload characteristics, speaker system testing, FM receiver alignment, preset frequency selection, communications receiver signal. Identification of diode and transistor. If the atom has 4 or more terminals and has form of chip, it is an IC, integrated circuit. If the atom has 3 terminals, it is a transistor. And if the atom has 2 terminals, it may be diode, LED, resistor or a capacitor. Transistor identification. Each semiconductor devices have a special numbering coding as per the specification of those components. All components have a particular symbolic numbering with alphanumeric coding for represent their characteristic of the material and other parameters. There is an international numbering system for all semiconductor devices and components. The first letter of the symbol indicates the nature of semiconductor material. A for germanium, B for silicon, C for gallium arsenide, and R for compound. If any transistor number is AC125, then it is a germanium transistor. And if BC148 is a silicon transistor. The second letter of any symbol indicates the device type and its function in the circuit. Example, C means small signal and D means power. Commonly, 2 letters and 3 number and 3 letters and 2 number are used. 2 letter and 3 number, example BF 194, are used for consumer equipment or for entertainment purposes, whereas the devices 3 letters and 2 numbers. Example, BFX63 components are used for industrial and professional use. In this slide, example of diode identification is given. If the code of the component is IN4001, means 1 is indicating diode, N is indicating semiconductor, and 4001 is a serial number of the component. In this slide, we can see different types of diodes. Here we can see different types of transistor and their symbol. Applications of diode and transistor. Diode are used in rectification, clipping, clamping, voltage multipliers, power supplies, and protection circuit, whereas transistors are used for switching and amplification purpose.